10.3. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. This means that minor arc AB, right here, and minor arc CD are congruent if chord AB, which is the line segment, and chord CD are congruent, which they are because we have these little hash marks. So now we know that these two chords, or minor arcs, are congruent also. Example 1. Use congruent chords to find an arc measure. In the diagram, circle A is congruent to circle D. B to C equals E to F, and the measure of EF equals 125. Find the measure of BC. Because BC and EF are congruent, then in the congruent chords, in congruent circles, the corresponding minor arcs, BC and EF, are also congruent. So, the measure of BC equals the measure of EF, and they're both 125 degrees. Theorem 10.4. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So, let's talk about perpendicular first. Perpendicular, meets at 90-degree angle. And then bisector. Bisector means cuts it in half. So we have these two little hash marks to say that this side is the same as that side. So this is a perpendicular bisector. If you have a perpendicular bisector, then it means that it has to go through the center of the circle. So if QS is a perpendicular bisector, then of TR, then QS is a diameter of the circle. So the opposite is if you have a diameter that's a perpendicular to chord, then the diameter bisects the chord and also its arc. So if we have this drawing and we know it goes through the center and we know it goes through this other chord at a 90-degree angle, then we can say that this side is that side and this arc is that arc. So we can say that arc DG is congruent to arc FG. A journalist is writing a story about 3 sculptures, arranged as shown at the right. Where should the journalist place a camera so the same distance from each sculpture? So first, we need to label these sculptures A, B, and C. Let's go A, B, C. Now we need to draw the segments A to B and B to C. Now, draw their perpendicular bisectors. Of A to B. Okay, by 10.4 theorem, these are diameters of the circle containing A, B, and C. Let's draw this one in too. Find the point where these bisectors intersect. This is the center of the circle through A, B, and C. And so it is equidistant from each point. So if we draw in the center here, we could draw a circle now, and it would go all the way around here, and we would have the same point radius to each of those. Use a diagram of circle E to find the length of B to D. Tell what theorem you used. So, solution. Diameter A to C is a perpendicular bisector, or perpendicular to BD. So, by theorem 10.5, AC bisects BD and BF equals DF. Therefore, BD equals twice DF, and that equals 2 times 6. So the whole thing is 12. Theorem 10.6. In the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So, if we have two chords and we can draw a perpendicular bisector through the center here, then we can say that those two lengths of those chords are the same. So, let's fill this in. AB is congruent to CD if and only if EF equals EG. Theorem 10.6. In the diagram of circle F, AB equals CD equals 12. Chords AB and CD are congruent. So by theorem 10.6, they are equidistant to F. Therefore, EF equals GF. So 3x equals 7x minus 8. If we add 8 to both sides, then we get, no, we don't need to add 8 to both sides. We need to subtract 7 from both sides, 7x. Get negative 4x equals negative 8. Divide by negative 4, so that equals 2. So EF equals 3x equals 3 times 2 equals 6. Again, make sure that you don't get just x, that you go back up here and read what you really need to do and find the measure from EF. So you need to substitute back in here to get the real measure. Okay, checkpoint. Go ahead and do these three.